Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using the angle sum and difference formula of sine, cos, and tan. So I'll just explain quickly how to use these formula. So because there's a plus on top here, it goes with the plus here. If it's sine of alpha plus beta, you add the two terms. Sine of alpha minus beta, there's a minus between them. So for cos, it's the opposite. Cos of alpha plus beta, you actually subtract the two terms. This negative goes with this plus. Same for tan. If it's tan of alpha plus beta, plus on top, minus on the bottom. And the opposite, if it's tan of alpha minus beta, minus on top and plus on the bottom. So make sure you learn these formula. They are very useful. The reason they're called sum and difference formula is obviously because there's a formula for adding two angles together and then taking the sine, cos, or tan, and subtracting the formula, taking sine, cos, or tan. So we're going to use these formula to prove identities. We've looked at identities previously in this course. They're just formula or rules that involve the trigonometric ratios. So I'm going to use this formula up here to prove this, that sine of pi on 2 minus theta equals cos of theta. We actually proved this using right-angled triangles earlier, but now we're going to use the angle sum and difference formula. So obviously because we're talking about sine, I want to use this formula up here. Because there's a minus between them, I want to use the minus. So the formula for sine of alpha minus beta, so it's sine of the first term times cos of the second, because there's a minus in the brackets, a minus between the two terms, and then it's sine of the second cos of the first. So we know that sine pi on 2 is 1, cos pi on 2 is 0. So this will just reduce to 1 times cos theta minus sine theta times 0. Of course, this just becomes 0 and it's just cos theta. We have proved what we set out to really easily using the angle difference formula for sine. Let's look at another example. So I'm going to prove what's known as the half angle formula for sine, that sine of theta on 2 is equal to this. Now note this equation has a sine theta on 2 and also a cos theta. So I can achieve an equation that has both of those things if I find cos of theta on 2 plus theta on 2. So cos theta on 2 plus theta on 2 is of course just cos theta. But the angle sum formula for cos says when it's cos of alpha plus beta, it's cos of the first times cos of the second minus sine of the first times sine of the second. So as I said before, this here is just cos theta. And I can write this as cos squared theta on 2 minus sine squared theta on 2. See, the problem is now this has a cos of theta on 2, whereas I don't have that in what I'm trying to prove. So I need to get rid of this somehow. Now, what I can do is use this identity that keeps coming up. Because cos squared theta plus sine squared theta equals 1, rearranging that equation, I have cos squared theta equals 1 minus sine squared theta. So what that means is I can rewrite this as 1 minus sine squared theta on 2. So now I can just combine these two terms and make this 1 minus 2 sine squared theta on 2. So now I know I'm on the right track because I've got an equation that just has cos theta and sine theta on 2. All I need to do is make sine theta on 2 the subject of this equation. So I'm going to start by subtracting 1 and then dividing by negative 2. So because I have a negative here on the bottom, I can turn this into a positive if I multiply the top by negative 1. So when I multiply the top by negative 1, it just switches these around so it becomes 1 minus cos theta. So now I have to undo squaring, because I don't want to square my answer, by square rooting both sides. And so I have to account for the fact that the answer could be positive or negative, but other than that, I've proved what I set out to. So this formula is saying sine theta on 2, sometimes it's the positive square root of 1 minus cos theta on 2, sometimes it's the negative square root of 1 minus cos theta on 2. Of course, this depends on which quadrant theta and theta on 2 are in. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.